Here we have a SAT math question. Okay, let's go the information. An economist modeled the demand Q for a certain product as a linear function of the selling price P. The demand was 20,000 units when the selling price was $40 per unit, and the demand was 15,000 units when the selling price was $60 per unit. Based on the model, what is the demand in units when the selling price is $55 per unit? Okay, so here the question clearly says that the economist modeled a linear function between the demand Q and the selling price P. So that is, we have to define the linear function by Q in terms of P, or we have to define the same linear function by P in terms of Q. So how do we have to define? So whether we have to define by Q in terms of P, or we have to define by P in terms of Q. So here the target of the question is to find the demand. Since we have to find the demand in units when the selling price is $55 per unit, so we can define this linear function by Q in terms of P, that is in slope intercept form, the linear equation in slope intercept form. So that is Q equals to M times P positive B. So now this is a linear equation in slope intercept form, that is exactly in the form of y is equal to mx positive b. Okay, whenever we have a linear equation in the form y is equal to mx positive b, the slope intercept form, each point on the xy plane will be written as x comma y. So for this equation, each point on the xy plane will be x comma y. So for this linear equation in slope intercept form, so what do we have to write? In what form do we have to write each point? So here at the place of x, what do we have in our equation? We have p. So we can replace this x by p, and at the place of y we have q. So we can write q over here. Okay, now in this equation, in this linear function defined by q in terms of p, our aim is to find the slope m and the y-intercept b. So once we get the values of these two constants, so this equation will be complete, and I can plug in this $55 selling price for p, and I can find the demand q. So now our aim is to get the value of m slope and the y-intercept b. So for that we have to use the information we have over here. Okay, now let's consider the first information, that is the demand was 20,000 units when the selling price was $40 per unit. So that is the selling price is $40. That is the value of P over here, and the demand is 20,000 units when the selling price is $40. So let me plug in 20,000 for Q. Okay, now let's consider the second information. That is the demand was 15,000 units when the selling price was $60. That is when the value of P is 60, the value of Q is 15,000. Okay, now I got 2 points. So for this equation over here, using these 2 points, I can get the value of the slope m. So whenever we have 2 points of a linear function, there is a formula to find the slope, that is m equals to y2 negative y1 over x2 negative x1. So we can consider the first point over here as x1 y1 and the second point as x2 y2. So we can plug in y2 for 15,000 for y2. Let me write over here negative, and 20,000 for y1. So let me finish writing over x2 negative x1, that is 60 negative 40. So m equals to, when I simplify this, I'm getting negative 5,000 over 20. So when I divide 5,000 by 20, I'm getting 250, but negative sign is over here, that is negative 250. So now I got the slope of the linear function over here. So that is the value of m over here is negative 250. So now let me write the equation with the value of m, that is q is equal to negative 250 times p positive b. Still there is an unknown constant b, which is called y-intercept. So how do we have to find the value of this b? So to get the value of this b, we have to use one of the 2 points over here. That is, okay, we can use the first point over here to get the value of b. That is, I have to plug in 40 for p and 20,000 for q in this equation. So let me do it. So 20,000 equals to negative 250 times 40 positive b. Okay, so 20,000 equals to negative, when I multiply this 250 and 40, I'm getting 10,000. So let me finish writing. So to solve for b, I have to get up this negative 10,000. For that, I'm adding 10,000 to both sides. Let me finish doing. When I do so, this negative value, positive value will cancel out. I'm getting 30,000 on the left side. On the right side we have b. Now I got the value of b. So now what I can do is I can plug in the value of b over here in this equation. Okay, now let me take the equation over here. That is q equals to negative 250 times p positive. The value of b is 30,000. Just now we got it. Okay, now the equation or the linear function which connects the demand q and p is complete. Okay, in this linear function, what I need to do is I have to find the demand when the selling price is $55. That is, I have to plug in 55 for P and evaluate the value of Q. Then Q is equal to negative 250. So now I plug in 55 for P, positive 30,000. So Q is equal to, when I multiply this negative 250 and 55, I am getting negative 13,750, positive 30,000. Okay, in the next step, I'm going to combine this negative 13,750 and 30,000. When I combine them, I am getting positive 16,250. That is, when the selling price is $55, the demand is 16,250 units. We find this 16,250 in option A. So the correct answer choice for this question is option A.